SQLXPress stores execution plan information in its own database rather than regenerating plans dynamically for every function. This allows us to perform a number of useful tasks when optimizing query execution. Work with execution plans to access this database. The first thing we can do is report on execution plans that display particular attributes of queries that we're interested in. Select query execution plans to generate these reports. The first page limits the types of objects we're looking for. In this case, select standalone queries, which are queries that have been manually entered, or scan for MES tracing of the ODBC and JDBC activity. The second page identifies the actual activities we're looking for. There are several properties to choose from, but for this example, we will look for queries with high statement cost. So you click continue, press continue, and go to the next step and execute the query. From the list of entries, we can select a query of interest and display the execution plan for our review. SQLXPress makes the plan more readable by displaying it as a tree. Each pan fragment is color-coded, displays the type of operator, the name of the object to which the operator applies if appropriate, and the percentage of the time that is spent within that operator. Above each node is the number of rows that would be expected to be returned from that node. And the plan's percentage is also displayed as a red bar to the right of the node to highlight points of high percentage. In this case, we can see that 73% of the plan is spent on a file scan of X221DET. Also, if you hover over a node, the details of that node will be displayed. Those details can also be displayed by going to the Details tab for the text view of the plan, which can be browsed through this way, or you can select a node to navigate through the different steps of the plan. Select the Summary tab for a grid display of the plan operators, as well as the most important attributes of those operators. Select the SQL Statement tab to display the text of the query. Now, once you've done this, a more comprehensive way to analyze your query is using the Query Advisor. So from the select the Execution Plans page, select Use the Query Advisor. Similar to the Query Executions Plans page, you can choose to work with programs for static SQL, SQLXPress queries, or MFC locations. Press Continue to choose which queries we're interested in. And in this case, we'll choose QR* to select that query that we were looking at before. Press Continue to select the advice thresholds. These are rules of thumb that are used to generate various recommendations. For instance, the default of 60 days indicates that the statistics have not been updated in the last 60 days, and that will trigger a request to update those statistics. So once you've been happy with those settings, you fetch the queries that you're interested in this case just the one, and press the Generate button to actually generate the Query Advisor. Once the analysis is done, you press Continue to display the results. This will recommend environment changes to improve the query performance, such as adding indexes right here, or updating statistics, which come up under the Tables tab. The advisor will also suggest syntax changes sometimes, for instance, using equal instead of like, or replacing the join condition to make a query function more efficiently and provide the same results. Now, once we've found our query, and if the Query Advisor doesn't give us what we need, or if we want to take advantage of some of the syntax checks and try to change them, we use the prototyping tool, the Query Tuner. So you select the Tune a Query from this page, which starts the Query Tuner. And that allows you to perform an index depth analysis of the effects of changing a query and taking multiple snapshots of that query. Okay, so first we'll open the query we're interested in. Now these are stored in multiple snapshots, each of which represents one execution plan generated. This allows us to easily compare the effects of changes we make to our query. Okay. The Execution Plan tab displays the execution plan in much the same way as you saw in the SQLXPress client. The Execution Statistics tab gives us information about the query in a more easily accessible method, because SQLMX query cost is a very esoteric number. It's difficult to relate that to real world terms. So what the Execution Statistics page does is allows you to run the query. So if we click Run Query here, it will take the current query and execute it, although it will not return results. You can run the query multiple times if you would like to avoid cache bias, which results in uneven response times based on data returned from the cache rather than from disk files. And this will give us, in this case, you're looking at execution time, compile time, which is a much more meaningful number than SQL cost. Lastly, the Performance Charts tab lists the query's performance between snapshots. In this case, we can see that using the control query defaults for nested joins, which is what we did here, so we'll go back to the previous snapshot. You can see that when we wrote our query, we put in control query defaults to use nested joins rather than merged joins, and the performance chart for that query shows about a 10 times factor improvement in response time.